Hey guys, so today we're going to be working on Lab 8, which is the SSH, OpenSSH connection lab. Allows us to remotely connect to a Unix or a Linux server, and we're going to be using an application called OpenSSH, which is native to Windows, and it's easily used from the command line. So let's go ahead and get started. Alright, so here we are. I've opened a DOS prompt. Now you can do this from command line like this, or you can use PowerShell if you choose, but the preferred method for this lab is going to be just a regular command line. So what we want to do in order to connect, first thing we need to do is type in SSH, and that tells us what kind of connection we're making. And we're going to use our username. For this machine, your username should already be established, your account. So your username is going to be your first initial, last name at, and then the host address is Linux, cosc.grayson.edu, and we're going to hit enter. Now, it's going to ask for a password. In Linux, you don't see anything when you're typing a password. You're just going to see a blinking cursor there. Don't panic. It's actually typing in. So you're going to type in capital P, little a, $WORD1. And sure enough, you've been logged into a Linux server on campus. The port that you just used was port 22. It's possible to use different ports if the server that you have is set up for a different port. We're not going to do that, but I just want you to know that that's possible. You just have to tack it onto the end of your command. Look under the help file for OpenSSH to get more instruction on that. Right now, though, we are currently logged in, and so what we need to do now is we need to follow the instructions that we were given earlier. So the first instruction tells us we're going to create a file named junk using the touch command. So to do that, as I pointed out earlier, our commands are available on the last page of our lab. So there are the 7 commands that we're going to use, and the one that we're using right now is the touch command. Creates a new file, and you just say touch followed by the file name, which in our case will be junk. And so that's exactly what we're going to do right now. So we've got TOUCH, oops, I've got to keep it blinking over here, TOUCHJUNK, hit enter. It looks like nothing happened, but if we type in the ls-l command and we look at the things in our folder, what we find is a junk file that we just created today, just now, in fact, at 12:10. Permissions currently it has are read-write for me, read-write for my personal group, and then read-only for the rest of the users of this computer. So if I were worried about permissions, those are what I do. That's what this -L at the end of the list statement accomplishes. When you put -L as a parameter on there, it allows you to see the permissions. I'm going to go ahead and get rid of this trash file because I don't need it yet, and use the rm command. Now I only have the junk file, so I deleted or removed that trash file. Alright, so I have the file that I'm supposed to have. The next instruction tells us that we're going to copy that file to a new file called trash using the cp command, which is basically just copy. And the syntax is the same. You cp, and then the file that you want to copy, which is junk, and the file you want to copy it to, which is trash. Now, if there's already a trash file, it will copy the data into that file. If it's not, it will create a file and then make it an exact copy of the first one. So we hit enter, and now we do ls, and we find we have a junk and a trash file, both of which have the same permissions, and both of which are inside our folder here. Okay, so the next thing we want to do is we're going to rename the junk file, and we're going to use the move command. Now that doesn't seem like it would make a lot of sense, but the move command basically takes a file and rebuilds it as a different file with a different name if you choose. So what I'm going to do is I'm going to type in mv, and the file I want to change, which is junk, and the name I want to give it is garbage. So I'm changing junk into garbage. Seems kind of odd. Once again, it doesn't give you any indication that it's done anything, so you have to hit ls-l. And now instead of a junk file, we have a garbage file. So we have garbage and trash both. Alright, and the next thing that we want to do is delete the trash file using the rm, or remove, which I did a while ago, but I'll do it again since we have a new one. rm trash. So we're going to carry out the trash, so to speak. And now, ls-l. I would warn you that using the rm command, there's no are you sure, there's no recycle bin, nothing like that. When you do it, it's gone forever. So make sure that you want to remove the file before you do so. Excuse me. Enter. And now we only have a garbage file. Our trash file is gone. We have gotten rid of that. Alright, so now with our garbage file, we're going to change the permissions using the chmod so that we are the only ones who can read it. So we're going to get rid of all the permissions for anybody else. And to do that, we're going to go to the last page of our lab manual, and we're going to look at the format. So you're going to do chmod, and using the gr will remove the readability from the group. So we're going to use that, and then we want to also we want to remove the ability for everybody else to be able to read it. So essentially we're going to use the gr command, and let's see how that works for us. So type in here, we're going to type in chmod, and that's change mode, and g-r, and then the garbage file. And when we hit enter, still again there's no impression that it did anything, but if we do ls-l now, we find that the group no longer has read permissions. They still have write permissions, which is insane because they can't open the file to write to it, but they can read it. So now let's go ahead and look at let's look at what another one can do. Okay, what others can do, we want to get rid of their permissions, and so instead of using g-r, we're going to use o-r. So let's go chmod, we're going to do o-r. So G stands for group, O stands for others, and then M stands for, or U, pardon me, not M, but U stands for user. So this is how we're going to get rid of what the others can read. So we're going to get rid of that, and we're going to go garbage, ls-l, and now I can still read it, but nobody else can. Now the group can still write to it. So what we would do here is we go chmod, and we're going to do g-w, and this should get rid of that permission as well. And so now, yes, the only person that can do anything to it is me, and I can read and write. Ideally, we could get rid of since the directions specifically say make it where only I can read it, we could get rid of this write permission. We could make this a read-only file. To do that, all we would have to do is chmod and then u-w. So what we're doing is the first letter is the group, whether it's user or whether it's my group or whether it's everybody else, the others. And then if I'm subtracting an R or a W, that means read or write. So if I get rid of this W, now I can only read this file. That's if I open that file, all I can do is read it. I can't change it in any way, and nobody else can even open it. So I've done what was intended. Now, what I'm going to do is I'm going to put the W permission back on for me. I'm going to make it rewritable. This is not in the lab. I just want you to get an idea of what you're supposed to, how you're supposed to use the chmod command. So I'm going to type in chmod again, and this time I'm going to go user plus W. And what I'm doing is What I'm doing is adding the right permission back to me. And I hit enter. ls-l. And now as you can see, I have my right permissions back. So what happens basically is the first part of the chmod property, or parameter rather, is the group that's affected. Of these three groups here, of this permission, first of all, let's go back and give everybody full permission. Let's make this a teaching point. So I'm going to go chmod 777, and what that means is everybody can do everything. So now, as you can see, everybody has read, write, execute, read, write, execute, read, write, execute. That means this triad, oops, pardon me, this triad is me. The first one is the U group, user. The next triad is the group. If there are people in my permissions group, they also have read, write, execute. And then the final one is everybody else on the computer that's not in my group. Those people have also now read, write, execute. Now, the sections here, there are three sections: user and others, and pardon me, user, group, and others. And these are the three permissions they have. So if you look at the last page of your lab sheet, those are the triads that they're talking about. First triad, that's me. Second triad is group. Third triad is others. As I use the chmod command, I can take away or I can add permissions based on the plus and minus sign and based on the group. So if I want to take away all permissions from the others, then I would go chmod. And the first thing I'll type is others. So that designates what group I'm editing. And then I'm going to say subtract. And that says I'm getting rid of a permission, not adding. And let's say I want to get rid of execute for them. I'll do X. Now, and notice I still have executable permissions. The group still has it, but the outsiders, the others, have lost it. All right, let's do one more. I'm going to get rid of read permission for my group. So the group, and they're going to lose read permission for the file. And then ls-l. So now I've still got full permission. The others have read and write, but they don't have execute. And my group has write and execute, but they don't have read permission. So I can use the minus sign or the plus sign. I can use R, W, and X, which is read, write, and execute. And the first parameter here is the group that I want to assign those things to. If I put in 777, that just means everybody has full permission to do everything that they want to do. So, all right, but let's go back to where we were, and let's get rid of and put this back like it's supposed to be. So we're going to get rid of all the permissions for all the groups except me. So let's do chmod. We're going to start with others minus, we're going to go read, write. And I'm going to try this and see if it will let me use multiple parameters. I may have to separate these with a comma. Nope. I forgot to put the file name in there. That's bad. Let me try it one more time. 0 minus RW. Yep, there it is. You don't have to separate them with a comma. And now we do ls-l. And now others have no permission. Now I'll get rid of the permissions for the group. Do that. We're going to do group minus wx. Garbage. And ls-l. And now I'm the only one, and it said to get rid of everything but read. So I'm going to get rid of that. User minus wx. And that should leave me back with read, and that is who I'm supposed to. So hopefully that makes things a little clearer about the chmod command. All right, guys, so you have a little bit of a taste of Linux/Unix, and you learned how to connect with a chmod, chmod, with a SSH, OpenSSH application built into Windows. This will work on any SSH server. As far as I know, it will connect to any flavor of SSH as long as you know the host name, and as long as you have an account established, you should not have any trouble. This is usually used for administrative tasks, and like we were doing some file operations, and you can also read log files, you can start up applications, you can do all kinds of things. So this is a very useful thing. If you're going to be an administrator on a network, this is a thing that you're definitely going to be using a lot. So hopefully this helps. Once again, if you have any questions, I can be reached through the Canvas inbox, and hope to see you in class. Have a good day.